In this video, we're going to discuss histograms. Histograms are a great way to display quantitative data. And they're a great extension to our frequency tables that we've already learned how to create. Histograms will give us the general shape of the data, how similar our data values are to one another, how spread out they are. They're just a great visual to better understand the quantitative data that we might be faced with. So for this video, I decided to use some pulse rates that were recorded in beats per minute for 28 students in one of my statistics classes. So basically I asked the students, we timed for 30 seconds how many times they felt their pulse rate, neither their wrist or their neck. And then we doubled that value to approximate their pulse rate in beats per minute. And that's why all these values are even. I don't know, as a statistician I would look at this and be like, that's a little odd, all the values are even. So I just wanted to explain to you how we came up with these numbers in class. And so these are pretty decent approximations of the 28 students' pulse rates. So the next thing I'd want to know is, well, what was the shortest pulse rates, or the smallest pulse rate I should say. And that would be a minimum here of 52 beats per minute. And the largest value in our data set, the maximum, is 92. So we can see here this is the general span of the data. Let's see, and we would like to kind of talk about how we should organize this. I think that a good way to organize it would be to think of, well, let's group all together the pulse rates that are in the 50s, and then another classification of pulse rates that are in the 60s, 70s, 80s, 90s, etc. And so in order to accomplish that, I might take my data, as you can see here, and in any way or fashion you might like to do this by slashing them out, like as you're going to see me do. I'm going to circle and box them in with different shapes so that I can keep my eyes keen on finding the different values and tallying up how many are in each of those classifications. So I'm going to start with some funny symbols and start to figure out how many are in the 50s. And if you see here, I have 3 data values that are in the 50s, and I might jot that down on some scrap paper for myself. And then I'm going to go through and look through and try to figure out how many are in the 60s. 3, 4, 5, 6, 7. So it's 7 data values, or pulse rates I should say, that fell into the 60s. Same thing with the 70s. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 that were in the 70s. 80s, 1, 2, 3, 4, 5, 6. And finally, the 90s. 1, 2. So if I take all that and I've jotted it down, I can create what's called a frequency table that you've seen in prior lessons. So here's that idea of the 50s, 50 to 59, 60 to 69. So these are essentially our classes for our frequency table. And we would say that the class width here is 10s, because if you look at consecutive lower limits, you can see they're all different by 10 if you subtract them from one from another. Likewise, it happens with the upper limits as well. Here are the 59s and the 69s. So going back to that piece of scratch paper I may have, I remind myself that I had 3 students that had a pulse rate in the 50s, 7 for the 60s, 10 students with pulse rates in the 70s, 6 with pulse rates in the 80s, 2 that had the pulse rates in the 90s. So this is a frequency table. And what a histogram is a graph. Now this is a table. Some people might call it a chart. But what a histogram is a graph of this information. So it's just displaying it as a graph rather than a table. So along our horizontal axis, or our x-axis, if you might think of it from an algebra class, we're going to have the first column, pulse rates. And along our vertical axis, or the y-axis, we're going to put frequency. And another thing to check, I just noticed the 28 popped up, is that when you add up the frequencies that you tallied, you want them to add up clearly to the number of values that were in your data set, which was 28. So this is a good thing. If it failed to add up to 28, maybe added up to 26, I might have skipped a few in my tally, or if it added up to more than 28, then I double counted a value that ended up either twice in one row or maybe inadvertently counted it twice and ended up in two different rows of the table. So here's that horizontal and vertical axis I was speaking about. Here's our number line, 50 to 100, and just easily spaced out by tens here. And then here are our frequencies here. So that first classification we have from 50 to 59 had 3 students. And so what we're going to put here along the horizontal axis between 50 and 60 is a box that has, or a bar you might call it, that has a height of 3 that corresponds to the number of students that fell into that classification. Again, the next one, in the 60s, we had 7 students. So you can notice I have an equal width bar because this is the 60s that cover from 60 to 69. There's 10 different pulse rates that could fall in here. 10 different ones that could fall in here, so they're equal width, and it has an approximate height of 7, as you can see here. 10 students had pulse rates that were in the 70s. So this equally sized bars being placed next to one another. 6 students, you see the height there is 6, that fell into the 80s. And finally, 2 students that had pulse rates in the 90s. So the purpose of a histogram is to, again, show us a visual of the frequency table, but also it's to give us an idea, as you can see, how the data is spread out. 10 students, or the majority of our students, if you look at these middle 3 bars, had pulse rates somewhere between 60 beats per minute and 89 beats per minute. Right there. And that's pretty typical of a college class. And so it kind of gives us an idea of how the data is spread out along the horizontal axis here, along pulse rates, how they're spread out. Not so many students with the rapid pulse rates in the right, not so many students with the really slow pulse rates in the left, but the majority of the students are right here in the middle. Now, if you remember, we also learned how to describe histograms. So this has unimodal, one major hump in the data, and somewhat symmetric. You can see that it starts to stair-step down, not exactly, but kind of the same stair-step pattern on the left as there is on the right. So one might call this a unimodal symmetric histogram. Okay, the last thing I want to talk about on this slide is sort of this case of the 60, 70, 80, 90. You know, it's right there between 2 bars, but what bar does the pulse rate of 60 fall into? And when you see these cut points that are here, the one on the right of a bar will fall into the next bar. So 60, if there's anybody in our class that has a pulse rate of 60, would be placed into the bar to the right. And that's the case with all of these. If there were a 70 in our data set, which I believe there were, it's classified into this bar. So it's one of the 10 here, 80s, etc. So that's always sort of an interesting thing when you have a number between 2 bars. Well, which side of the line does it fall to? It always falls to the right. I want to take a minute and show you how to create one of these in Statcrunch. So if you log into Statcrunch, you can look for some data called pulse rate that I've stored there. You can explore and find the data pulse rate. Do this at a later time or pause the video and do it with me. I want to show you how to create a histogram in Statcrunch. It's pretty simple as long as you have your quantitative data here in one column. You can see there's all 28 of my students there. And I'm just going to grab the graph button, scroll down to histogram. Now, what's easy about this data set is I only have one column, so I'm going to select that one over and press compute. There's a lot of options and things we can change down here. We'll talk about those in a moment, but usually I just select the variable of interest, that's quantitative of course, and press compute and see what kind of decision that Statcrunch might make in organizing this data. So if we take a look here, it looks like Statcrunch decided to use a smaller class width than we did. you can see here, if I let my mouse hover here on this bar, you can see it goes from 50 to 55, not including 55. For you algebra people, you understand that the parenthesis to the right of that 55 means not including 55. So this bar right here is 50 to 54. This is 55 to 59, etc. So it chose smaller class widths than we did, which is fine. It has a default setting in it that it has to make a decision of some sort to show you data, and it decided to do this organization. I would still call this unimodal, somewhat symmetric, but if we really wanted Statcrunch to make a histogram that looked like the one we had envisioned, or maybe we sketched by hand, we can override some of the decisions that Statcrunch makes. If you click on Options and Edit, it'll back to that pop-up screen before, and we can tell Statcrunch, hey, these bins or these bars, a lot of statistical programs call them bins, we want you to start at 50. And we want our class width, we chose in our frequency table to make it 10. So you can override the decision that it made on its own. And if we hit compute, we see a very similar histogram to the one I had put up on the screen earlier. 3, 7, 10, 6, and 2 as the frequency counts. And you can see there are our 1, 2, 3, 4, 5 bars. I hope this was helpful. Shoot me an email if you have any questions. Thanks for watching.